Cisco instructor Andrea here. Again, Module 2 for our CNT 150 class is pretty much all review. I'm using these videos just to capture some of the more important stuff about the switch. In our previous example and video, we actually looked at how a switch builds its MAC address table. Another important concept that I do want to cover is the concept of flooding and using broadcasts. So again, we'll use the magnifying glass as well as, I think, a simulation mode in Packet Tracer to understand a little bit about that. Notice here all I have is a LAN. All of these devices are on the same LAN, and as of yet, there's nothing in our table. So if we come over here to PC0, and let's say I'm going to ping PC3, right? What do we predict will happen? Well, I hope what you're predicting is that PC0 will send the ping, it will hit the switch. So the first thing is it's going to fill the MAC address table with the MAC address of PC1 and associate that with F01. The next thing that will happen is it will flood out all of the ports except the port that the message came in on, because it's going to be looking for 192.168.10.4. And since there's nothing in the MAC address table, it doesn't know where to forward it. So let's just go to simulation mode. Okay, so again, from PC0, I'm going to do a ping over here to 192.168.10.4. 192.168.10.4. Again, what's going to happen? We should see a couple of ports and MAC addresses filling our table, and we should also see some flooding. So we're going to ping, and there is our ping. So first of all, we've already learned the port number, right? F01, that is associated with this PC and its MAC address. And I can look right here and I can see that. If we hover over the PC, we can see what the MAC address is. Okay, goes kind of fast. All right, so what's next? Next will be the flooding. We should see this ICMP flood out F04, F03, and F02. Sure enough, that's exactly what it did. And we can see here, PC1 is dropping it. Why is it dropping it? Because it's not meant for it. PC2, it's dropping it. It's not meant for it. Recall that the other thing that's happening right now is there is having to be some resolution because at layer 2, only MAC addresses are being used. So the PCs are having to do an ARP function as well. Now this looks good, right? It's not been dropped. The reason it hasn't been dropped is because the ICMP message was meant for PC3. The next thing we're going to see happen as we continue to move through the simulation is our MAC address should be able to get some information off of the ingress port F04. So we're going to send back because PC3 is going to reply, and voila, here we have port F04 has been recorded into the switch's MAC address table. It's also associated the MAC address that is associated with PC3. And then it's going to go ahead and it's going to respond to PC0. If I also inspect the ARP table now of the PC, we'll see that it has associated the IP address that it was pinging, which again is this PC3 192.168.10.4, and it's also recorded its MAC address. And again, it's doing this so that it doesn't have to constantly relearn information when it wants to ping and or send out information. If we were to be able to do another ping right now, what we would see is that this device would not have to do a broadcast anymore. The switch wouldn't have to do a broadcast because it's already learned PC3's information. Now let's go ahead and we can run, if we run a ping from PC3 to PC0, it also will not have to flood because the switch already knows the information. So let's take a look here. Okay, so here it is, and we're going to be pinging PC0. So let's see what happens. It should not flood because now it knows. Okay, there it goes. And it goes straight to PC0. So that's the difference that the MAC address table can make, is when the information is recorded for the ports and the MAC addresses, flooding doesn't have to happen.